class, this is section 5.6. We are going to learn about rhombus, rectangle, and square. And then we will have several conjectures concerning the three parallelograms. So let's remember the definition of a rhombus. A rhombus is a parallelogram with four congruent sides. And remember, a parallelogram is also a quadrilateral with both pair of opposite sides parallel. So let's open up Sketchpad, and we are going to construct a rhombus. So we're just going to start with a circle, and then we're going to make another circle with the same radius as the first one. So I'm just going to click on that point and draw it back to the other one. So I have two congruent circles. And then I am going to mark the 2 points of intersection. Make sure both circles are highlighted. And that will construct a rhombus. So I'm going to connect my points. And I'm going to hide my circles. Feel free to put me on pause at any point if you need to get caught up in Sketchpad. So I can take this point and I can drag it, and my rhombus will stay a rhombus. Okay, so what do we know about a rhombus? And let's make our markings. We know the opposite sides are parallel. So I am going to make my parallel line marks. And then I also know that the opposite sides are congruent. So with my pen, I'm going to click on each side with one tick mark to show that the four sides are congruent. Okay, so now we're going to write some conjectures about a rhombus. So the first one has to do with the diagonals. So I am going to construct the diagonals. And see what happens. Okay, so there they are. The two diagonals. Let's see what's special about them. I'm going to move it around, change the size a little bit, and see if I notice anything that stays the same or changes. I'm going to make this intersection point in the center a coordinate point, and then I'm going to measure some lengths. So I'm going to highlight this point to the center and say measure distance. I'm going to measure the other distance, and I'm going to notice that they are the same. I'm going to do the same thing with the other diagonal. And look, those segments are the same. Doesn't matter what size I make it, it stays the same. So the diagonals bisect one another. If I mark this angle in the middle with my pen, look what happens. It automatically comes up as a right angle. If I measure it, the angle measures 90 degrees. So the diagonals bisect one another, and they form four 90-degree angles, which means I have four congruent right triangles in my rhombus. So I'm going to use my pen, and I'm going to make some tick marks here in the center. So line segment AB is congruent to line segment BC, and then line segment DB is congruent to line segment BE. And then I have these 4 right angles with all having the vertex of B. One other thing happens with the diagonals, with the 4 angles of the rhombus. So I'm going to measure those angles. So I'm going to highlight point D, A, B, and I'm going to measure that angle. And then I'm going to measure angle BAE. I get the same degree. Do you think the same thing happens at angle E? So if I measure AEB, I get 30 degrees. So the diagonals are also bisecting the angles of the rhombus. I'm going to go ahead and just measure them all and make sure it's consistent all the way around. And it is. So now it's time to write a conjecture. So go ahead and take a screenshot of your picture, and we're going to write some conjectures. Conjecture 49 is called the rhombus diagonal conjecture. The diagonals of a rhombus are perpendicular and they bisect each other. Let me change the font there. So the diagonals of a rhombus are perpendicular and they bisect each other. The second conjecture with a rhombus has to do with the bisector of the diagonals bisecting the angles. The blank of a rhombus blank the angles of a rhombus. So the diagonals of a rhombus bisect the angles of a rhombus. Okay, so those are the conjectures dealing with our rhombus. The next figure that we're going to talk about is that of a rectangle. Okay, and we're going to have one conjecture dealing with our rectangle. Let's remember what the definition of a rectangle is. A rectangle is a quadrilateral parallelogram that has 4 90-degree angles, or 4 congruent angles. Okay, so now let's go into Sketchpad and construct a rectangle. So I'm going to start with a segment. I'm going to highlight the segment and its two endpoints, and I am going to say construct perpendicular lines. Then I'm going to pick a point on one of the perpendicular lines that will be able to move around. I'm going to highlight the line and say construct perpendicular line again. We know the perpendicular lines will make my four angles 90 degrees, and that's what we're looking for. So then I'll find the other point of intersection, and I am going to construct segments. Now I'm going to go ahead and just highlight all four, construct segments, and then I can highlight the lines and hide them. So then I'm just left with my rectangle, and I can slide the point up and down to make the rectangle the size that I want it to be. Okay, so then with my pen, I want to mark the four right angles, and I want to mark the opposite sides congruent and parallel. So I'll put one tick mark on the opposite sides, two tick marks on the other sides, and it's also a parallelogram. So we want to remember that the opposite sides are parallel. I'm going to make this just a little bit larger. And then I am going to construct the diagonals. So a rectangle has all of the characteristics of a parallelogram, and it has the four right angles from its definition. I am going to measure the lengths of my diagonals. And I see that they're the same. Do they stay the same no matter the size? And it appears that they do. So my diagonals are going to be equal in length. I'm going to find that point in the middle there and measure the four lengths that are created when they bisect each other. And yes, they will bisect one another. They will not bisect the angles. You can see here that it's not going through straight through the center of the right angle, but the bisectors, or the diagonals, are bisecting each other, making each segment equal in length. It's demonstrated there if you look at the lengths. Okay, so let's snapshot our rectangle and input it with our notes. The diagonals of a rectangle are congruent and bisect each other. The rectangle diagonals conjecture, conjecture 51. Okay, and then we're going to have one last figure to round out this chapter, and it is the square. A square, as most of you know, has four congruent sides and four congruent angles. You constructed a square when we learned the definition back in chapter 1. If you have forgotten how to do that, here are the steps. So you can put me on pause and construct your square. in Sketchpad. So go ahead and take the time, make your square in Sketchpad. And then we're going to write a conjecture. And here it is. The square diagonals conjecture. The diagonals of a square are congruent, perpendicular, and they bisect each other. I want you to take the time with your figure that you've made in Sketchpad and use your pen and make the appropriate marks on your square, screenshot it, and put it in your notes. Conjecture 52, the diagonals of a square are congruent, perpendicular, and they bisect each other. Insert your picture. I will look at it in class tomorrow. Thank you. This concludes section 5-6 and chapter 5.